Alright, and welcome to 6-5, Circle Segments Review. Now this says find the length of ST, so let's just go ahead and highlight ST, put the letter X. When given SU is 4 inches, okay, and UR is 11. Now I think it really helps to remember that this right here is a tangent, and then this right here is a secant. And what's our rule? Well, we can say that our tangent squared must always equal the, I'll call this the outside, I'll just use out for abbreviation, the outside secant times the whole secant. Okay? So what would this look like? Well, let's say our tangent is x, so we square it, x squared is equal to, our outside secant is 4 times, and then remember though, this is where they're going to trick you up, is it's not that 11, it's the whole secant, and 4 plus 11 is 15. So 4 times 15. Alright? All you have to do is solve for x, and then you will have the correct answer here. Alright, let's move on to our next example. Okay, here's problem 14. It says, given KJ bisects LM. Okay, let's see. So, if KJ bisects LM, that means that this right here has been cut into two congruent segments. And we see that NM is 4.8, which means that LN must also be 4.8. So that's what that information from the bisecting comes from. It's telling us that LN is also 4.8. We're also given that NG is 2.3. And we want to find the length of HN. Okay, so I'll put a little question mark there. Now this is really tricky. And the reason it's tricky is because we actually can't find HN immediately. So what I want you to understand is, let's just say, you know what, this whole line right here, let's call that X. Now here we have a diameter and a chord. Okay, so this one will require a little bit of setup. Here's our diameter, and here is our chord. And we know in this one, it's really the part times the part is equal to the part times the part. So what do I mean by that? I mean, we have this first very large part X, so we could say, you know what, X times the next part right here is that small 2.3, and of course that will equal the 4.8 times 4.8, but we can actually just write 4.8 times 4.8, that's 4.8 squared. Now what's 2.3 times X? Well, 2.3 times X is just 2.3X is equal to, and what is 4.8 squared? Well, for this one I'll have to get my calculator. And if you're more comfortable just writing it 4.8 times 4.8, that's fine as well. So 4.8 times 4.8 will give us 23.04. And we divide both sides by 2.3, divide by 2.3, divide by 2.3, and we're going to get this. X is equal to 10.02. Okay, so X is equal to 10.02. Now, why is this so tricky? I want to draw y'all a little diagram over here. Let's say here is KH. Let's say here is HN. And let's say here is NJ. We know NJ is 2.3. And we know that KN, my apologies, KN is 10.02. So this gets a little bit tricky because we are searching for that right there. So what in the world are we going to have to do? And let me pause this and really clean this up to kind of finish this off. We see here that we can actually get the entire length of KJ. We can get the entire length by adding 2.3 and 10.02. So let's do that right there. And let's actually call that what it is. It is a diameter, or it is the whole length here, by doing 10.02 plus 2.3, which will actually give us 12.32. Now what if I asked y'all to find the radius? Okay, well remember, to go from the diameter to the radius, we simply divide by 2. So if I were to do 12.32 divided by 2, that should be 6.16. There's our radius. And you'll notice that KH is truly a radius, 6.16. So with that given information, you can now take the whole line kn and subtract that 6.16 to find your value of y. That's what makes this such a difficult problem, is you have to have a solid understanding of what a diameter, a radius, what they are, and a very strong understanding of the segment addition postulate. Alright, I hope that helped. Okay, here we have another situation like the previous one. However, we don't have a diameter, we have two chords. I know that they're two chords because let's say, hey, you know what, that's the center. As long as either line misses it, we know that they are chords. And what's the rule for chords? Well, it's just the part times the part is equal to the part times the part. So what does that look like? Well, let's kind of set this up. Let's say, you know what, maybe in this nice little blue color here, let's say that IL times LH must be equal or congruent to JL times LK. Alright, let's go ahead and plug everything in. So we know that KL is 12, so KL is right there, that's 12 times. We see that LJ is 3x plus 16, so 3x plus 16. And that must be equal to IL, which is 20 times LH, 2x plus 6. 2x plus 6. Now, the trick here is a lot of times students forget to distribute, so I'm going to do the distribution with you, and then I'll leave you to finish this on your own. So this 20 has to multiply by both terms. 20 times 2x is 40x plus 20 times 6 is 120 is equal to, and here this 12, even though it's on the other side, it's still being multiplied by the whole parentheses. We still have 12 times 3x, which is 36x, and 12 times 16, so 12 times 16, which is plus 192. Now I will leave you to solve for x. And just remember, whatever x is, you're then going to have to plug it back in to find the length of jk. Well, jk is that whole thing. So how are we going to write up jk? Well, that's going to be that 3x plus 16 plus the length of lk, which is 12. So whatever you solve for x, put in right there and find that whole length of jk. Alright, let's move on to our last example. Okay, let's take a look at problem number 16. It says find the value of x when JL is 6x. Let's go ahead and start labeling this. We see JK is 34. Oh, interesting. So we're actually given the whole thing here, 34. JM is 20, okay, and MI is 22. Now, how can this get a little bit confusing? Well, it gets a little confusing because they've given us two scenarios. One, an easy one, and the other one slightly more difficult. So the first thing I would ask you to understand is that these are two lines that we call secants. What is a secant? It is a line that goes through the circle to the outside of the circle, alright, but it touches the circle in 2 points. That's what a secant is. And so what's the rule for secants? It's the outside secant times the whole secant is equal to the outside secant times the whole secant. So how can we write this up? Here JL is 6x, that's the outside times the whole, which is 34, equals, here the outside is 20 times, but notice 22 is not the whole thing, it's just a part. For us to find this whole thing, we actually have to add up our two parts, 20 plus 22, which would be 42. And so now I have that whole secant of 42. And from here, you can just go ahead and solve for x. When you solve for x, this is asking for the value of x. So, yeah, once you solve for x, you will be done. Whenever you find out what x equals, you are done. Alright, I'll see y'all in our next video.